Let's talk about safety. Mainly, what is safety's purpose? Because whether you're designing a safety system or you're troubleshooting a safety system, if we don't understand that, then we're going to really struggle. And I want to try to address a very discouraging comment that I get in a lot of my videos, and that is that we've never had an accident before. Why do we need all this safety? And first of all, you need to give some great thanks if you have never been in an industrial accident. Because if you have, then you'll 100% already understand the purpose of safety. Now, I don't want anyone to have to go through an accident to get here. But one, we do have the cost of either damage to equipment or harm to humans involved in that accident. But you also have an emotional cost to probably every employee in that building when a severe workplace accident happens. And so our goal in safety is to really minimize the opportunities for that. What I want to go through with you today is several safety systems and how failures in these could cause an operator to be put in harm's way. So first, we have call it our traditional MCR. So you're going to have a couple of inputs. In this case, I have two E-stops. They're in series, and they're coming down to this single contact. And we're going to represent that with light 1. And then we have our non-configurable safety relays. Sometimes these are yellow, sometimes they're orange, but typically you're going to have two contacts on your E-stops going down to these. And then you're also going to have two contactors in many cases on the outside of them. And then even in this case where we could push this contact in, notice these have windows here to prevent us from overriding them. And then I'm also showing a configurable safety relay here. Almost the same setup, only this one has a little more flexibility to this. And just because I already showed the three-phase version of the safety contactors, this one's just going to be used a little safety relay. And the goal of safety is to really eliminate those common failure points. Now, one easy way to eliminate failures is more robust equipment. And it could be as simple as that. If you have something that has a really common failure, then simply changing that out could be good enough. But another really often used way of eliminating these hazards is redundancy. So on our basic MCR, you would have an E-stop with a single contact, normally closed, something like this. Also, a lot of times you may see a normally open on these. That is not redundancy. Usually that's going to some type of light to tell you it's pressed. But this is a single point failure because this contact could get stuck. Also, the whole contact itself could just pop off the back of the block. And being normally closed on typical E-stops, it will not sense that that contact is off. So simply by adding a second contact to the back of this E-stop, we're going to reduce the likelihood of a single point failure. Now, before we even talk about the single point failure, let's just look even a little closer at the E-stop. Is this, you notice, has some symbols on it that tell you to twist it to release it. So you press the E-stop, that's going to lock it in. In this case, you twist it, and that's going to pull it back out. Now, a lot of people will say that this is the two actions of an E-stop. We press to pull it in, and we twist it to reset it. But that is not actually going to cover one of our single point failures. Because, in this case, if I press the E-stop, it drops out. Looks good. And we'll just concentrate on light 1. We pull it back out, then it comes back. So, it did take two actions. One to press it, the other pull it out. But now let's talk about it if an operator is in panic mode. And they run over to press the E-stop, and they don't get it all the way pressed. So now as their hand slides off of it, their machine is going to take back off. So we can't count on this twist being our reset. And you can tell that these two are accounting for that because they have the separate reset here and they did not come back on. But this one, If the operator doesn't get it pressed all the way in, it's going to take back off. Now let's get back to talking about our single contact e-stop failure. So if a contact gets stuck closed, or this contact comes off, or heaven forbid somebody jumpers it, which hopefully nobody in modern machines is doing now, then we'll have a single point failure. And I have switch 1 to simulate that. So pay attention to the 3 safety circuits. And if we press our e-stop, notice these 2 drop out, but this one doesn't, because both of these have redundant contacts on the back of them. And even though one of them failed, it noticed it on the other one. This one right here is similar to this. And yeah, we had that single point failure, and now our operator is in harm's way. Now, there's another step to this, and this one right here can really trip people up, is now that we have had one contact fail, you can almost imagine that contact's not there, and you're back to a single point failure on your system. So in addition to this looking for both of those contacts, it's also monitoring, are they moving together? So in this case, if this e-stop, the contact is broke, it's actually physically loose now, and we press this e-stop, it only saw the one contact move and this one stayed. So now when we reset this e-stop, it's going to be like, hey, these 2 didn't move together, and it's not going to let it reset. It's going to have to see both of these contacts move in and out together. So what I'm going to do is I'm going to pull my e-stop back out, and we try to reset it. It's not going to let us reset because we have that broken contact. Now, we fix our e-stop. It's still not going to let us reset. It's going to have to see a transition of both of those contacts going from false to true. So we press the e-stop again now that we're repaired, and we pull it back out. That's going to let it see that transition of trues and falses. And now to reset. Now the other side is equally of dangerous of a failure. Arguably, I would say this is probably more commonly a failure, especially on systems that people haven't thought about safety, is we have a single contactor here, and chances are we had a 9 amp load, so we went and got a 9 amp contactor, not knowing the difference between amps and horsepower. And so we are overloading this contactor. Well, as you overload a contactor, you're going to heat up those contacts. And as you heat up those contacts, eventually they'll melt. And yes, we're usually building that heat while a contact is energized, which means we have a high probability of a welded contact here. And so switch 2 simulates a welded contact. And if you pay attention in these 2 windows right here, you're going to be able to see the gray even in the left one. It's going to operate, the right one won't. And you'll see this is going to stay stuck as well. And it's not as clear on this, but this one's going to stay stuck too. So that's going to simulate a failure of this contactor, and this contactor. So we press our e-stop, and you saw the gray pop out right there, but there is no gray popping out right here. So this contact is welded shut. This one did drop out. But notice in this case, our machine is going to continue to run. Our operator's in danger. Both of these did prevent our operator from being in danger. Now, similarly to our whole e-stop failure analogy, we are back down to a single point failure with this contact welded here. And this may be the most difficult one to troubleshoot. And actually, we're going to do some videos on troubleshooting these. But the normally closed that you see on a lot of your safeties is a feedback, making sure that all the outputs dropped out. And if it does not have continuity through all of those, then when we pull our e-stop back out and we try to reset it, it's not going to let us reset. So we're going to have to fix our feedback, which you'll see the contactors move. That's going to let continuity go through here. And that's going to get us back going. Now that we understand the purpose of safety, let's talk about some troubleshooting tips on safety. And in this playlist right here, we have videos on your standard safety relay troubleshooting, your configurable safety relay troubleshooting, and also safety PLC troubleshooting. Click here to follow me over there.